Hello, everybody. This is probably the first time you've seen me on camera before, but I wanted to share some research that I've been doing over the past 10 months. So, this January, I had an opportunity to present at the American Meteorological Society annual meeting in 2026. So I was down in Houston for about a week. I think I chugged out one video during that time, but I wanted to share this research with you guys as there is an available recording. Thankfully, due to the AMS, they have the recording up on their website. So I just want to share this research with you guys. Forewarning, there is a little bit of refraction going on in the recording, unfortunately. So if you have any question on this project, it does mean quite a lot to me. I've had a lot of fun time doing this project, learning more things, getting to work with it and such. So if you have any questions on this, please reach out, or in the presentation, because you can't see the words or whatnot. Again, reach out to me. I'm more than happy, and you can leave a comment on this video. But without further ado, please enjoy.
Speakers Ethan Palmsano from Valparaiso, and Ethan's going to be presenting an evaluation of SPC Convective Outlook Accuracy and weather conditions that produce difficult forecasts. Go ahead, Ethan.
Okay. Good afternoon. Just excited to share this research with you guys on convective outlook accuracy and weather conditions that produce difficult forecasts. I'm Ethan Palmisano, advisor Dr. Phillips is over there. So there are two main questions I want to answer with this project. One, how accurate are SPC convective outlooks? And two, what are the synoptic patterns that produce the most difficult forecasts? So I'm going to be doing that by verifying the convective outlooks, and then with those verifications, I'm using clustering to see which weather patterns do produce those difficult forecasts, the ones that don't pan out correctly. So start with some of the motivations behind this project. First off, what is an SPC outlook? This is going to be a probabilistic forecast of severe weather. You have the categorical outlook, as you can see on the screen there, but they also have probabilistic outlooks for wind, hail, and tornadoes, and that's what we're going to focus on in this project. The big thing to note also is the SPC are some of the best forecasters in the nation. They work very closely with the local WFOs during forecasts, so we definitely chose these because of the very thought out nature of the forecasts. So SPC outlook accuracy is a big part of using them as well. And why inaccurate forecasts? The big reason is because people are going to remember the days where your forecast went wrong. If you get rain and you didn't bring an umbrella outside, you're not going to be happy. So that's a big part of it. These forecasts being accurate is important for public safety, but also trust in future forecasts. As meteorologists, we can look at these past inaccuracies and try to improve for the future. But the SPC does not directly define what an accurate forecast is. So that is where my methodology will come in. First off, the SPC definition of a convective outlook. This is the best estimate of a severe weather event occurring within 25 miles of a given point. Again, as mentioned earlier, we didn't look at categorical risks, mainly due to just all of these different probabilities. If you have an enhanced risk of severe weather, that could be anything from a 10% probability of tornadoes, or a 30% of wind, or a 45% of hail. So we focus specifically on each hazard and their probabilities. And then finally, because of ergodic reasoning, the SPC's risk probability should equal its coverage over the risk zone. So we looked at 13Z day one convective outlooks from 2016 and 2024. We chose this time period because the marginal and enhanced risks were they began being issued in 2014. So we have 1 year of leeway for the forecasters to adjust to the new forecasting style. We use Iowa State's local storm report archive, and we looked at the highest daily risk based on coverage percentage. These were then classified under forecasts, accurate, or over forecasts. And then because of reports having a large impact to their 25-mile radius, we looked at risks with only greater than 10,000 square miles of area, just so that one report wouldn't lead to massive fluctuations in over forecasts or under forecasts. I'm going to provide a visual on how these risks are verified. So let's take our example, 10% probability for tornadoes. Here will be our verifications. There's our reports, and then here are your 25-mile radius circles around. You divide the report coverage area from those circles over the total risk area, and that will be your coverage percentage. For example here, this would be kind of our coverage percentage and how they are classified. So if you're in that 10 to 15 range for this example, 10% risk, that's going to be true accuracy right within, basically your forecast just hit the mark. If you're within one category of error, I did note slight over forecast and slight under forecast, but for the purposes of this, these are still considered accurate just due to being right within that category of error. But then anything one category or more, that would be considered over forecast or under forecast, so inaccurate. Like here's an example of an under forecast. You might look at this and say the SPC had that perfect risk area. You have all the reports right within it, but your 5% probability is not high enough. The coverage in that risk is probably much higher. I think it's about 80%. So that's an example of under forecast. And then with the data that we'll get from this verification, we're going to use k-means clustering to sort days into basically clusters of similarity. So basically an example of this, let's imagine these are our weather days. Let's start out with basically 3 kind of random points, right? And over many iterations, over time, these will get basically organized into 3, in this case 3, but in our case 18 clusters of similarity. So that's our final verification, for example. Let's say that red cluster is going to be northwest flow events in the Midwest, or the yellow is landfalling hurricanes producing a lot of tropical tornadoes. Basically, that's the idea of k-means clustering, and that's how we used it for this project. Here are the variables I used. At all levels, we used geopotential height and both the wind speeds, or both components of the wind. We looked at temperature and dew point for 700 and 850, relative vorticity at 500, and then theta E was used kind of as a proxy for instability at 850. And then over time, for each cluster, you would average out the data to create a composite synoptic chart. That's what we'll show in just a second. First, you have the risk verifications. Hail was the most accurate of the 3 hazards, with only 15% of risks being inaccurate, and that true accuracy percentage being very high at 28%. And again, remember that slight under forecasts and slight over forecasts are going to be put into accurate for the cases of the study. Next were wind forecasts. These were slightly less accurate, but still very accurate, about 82% of risks being accurate with this methodology. But lastly, tornadoes were the least accurate of the 3, still being at 70% accurate, but they do have the lowest true accuracy and also highest of under forecast and over forecast. For that reason, we'll look at tornado environments in particular. So out of the clusters, this is going to be our least accurate cluster. You can see pretty strong winds at all levels, especially 250 millibars. You can even see it all the way down to 850 millibars as well. Southwesterly flow is a pretty common component at all levels, especially low levels. And here is our, basically this is a heat map of all of the storm reports for this cluster. You can see our main 2 areas being the Midwest and the Southeast. And then looking at standard deviation maps, you can see this higher area of variability over the plains, basically over the Kansas and Oklahoma region. This could be hinting at shortwaves in the flow, helping to basically produce more under forecasts. As you can note, the title of this, it's also the most under forecasted pattern out of all the clusters. So that could be leading to short waves, leading to harder forecasts and more kind of surprise events. This is the most accurate cluster with about 6.1 reports per day with our heat map here. This is basically just a crop projection over the Rockies. If we remember the last map, much weaker flow overall. That last map had very strong winds at 250 millibars, but this one is much weaker overall. We do still have that trough ejection going on. You can kind of see the subtropical jet pushing up in there. And also with 850 millibars, that fairly unstable air mass across the US, but overall not very impressive winds. Reports are pretty much scattered across the country. They're not in a specific hotspot. If I had to place one, it'd be somewhere in kind of the upper Midwest, but overall there's not like that very strong hotspot as you might see in some of these other clusters. And regarding standard deviation, we don't see nearly as much of a hotspot as in the least accurate cluster, indicating that lower variability was helping with accuracy. Here's our most over forecasted pattern. You can note for sure the southwest flow at all levels, especially in the low levels here, and also the broader trough overall here. Strong upper level winds are again a factor here for this inaccurate cluster. Looking at the 700 millibars and 850 millibars, there's weaker low level moisture than we saw in our last composite map. Then lastly, with our heat map here, you do have a kind of stronger spot in the southeast that area of maximum report coverage. And you can see just that's the main area of where reports are happening for this cluster. Looking at standard deviation here, there is some more variability than we saw in the last one. Maybe you could eke out that maximum over in 700 millibars over Kansas, but there is a little less to be seen from this cluster. And lastly, this is our least under forecasted cluster, and also the second most accurate cluster out of the 18 looked at. This one has fairly zonal flow across the country. Again, not a very strong upper level winds. and also very inactive. Here's our heat map. And again, you don't have many reports going on here. So that's something you've seen in both of these clusters here. We had our most accurate cluster, fairly not much activity for the tornadoes. The same case here for our second most accurate, there's not much activity going on overall. And then our standard deviation maps, we don't have too much going on from the variability side of things. And as we saw in some of the other maps, we don't really have that pinpoint maximum anywhere. So for the conclusions, there was something I wanted to look at too, was where are the least accurately forecasted tornadoes and where are the most accurately forecasted tornadoes. So we're gonna look at 4 maps on both of these. These are our first 2. The one on the left shows, and that's that one we saw with the least accurate, with the 2 maximum, one in the Midwest, one in the Southeast. The second cluster here on the right doesn't really have as much of a defined pinpoint, but our next 2 clusters do really showcase that Southeast region of the US as a potential not under forecasted, but least accurately forecasted region. For the most accurately forecasted tornadoes, again, we did see this one on the left here. That one was, again, kind of that maximum in the Midwest, but again, overall fairly scattered. The same case with the one on the right. And then for these maps, we don't really have as much of a local maximums anywhere, maybe in the Southeast of the US. But either way, between these 4 maps here, these are the most accurate forecast tornadoes. There's not nearly as strong of a hotspot as we saw at the least accurately forecast tornadoes. So regarding conclusions, first off, how accurate was the SPC? Fairly accurate. The lowest accuracy was 70% for tornadoes, but again, wind was at 82, hail is at 85% of accuracy. Between the maps for the patterns that produce these difficult forecasts, the southwest flow over the Gulf Coast states especially was a common factor for those inaccuracies, and even across all levels of the atmosphere. And there is a case to be said for higher standard deviation, higher variability, leading especially to under forecasts, but even inaccurate forecasts on the whole. Then lastly, the southeastern US was a common location for these inaccurate forecast scenarios. So for any future work, I would love to look into the wind and hail risks. This wasn't in the time constraints. Hash risk would be interesting to look at as well. And then also messing with some of the parameters, maybe looking at Cape, et cetera. And then also answering the question, what caused that higher standard deviation? It's reasonable to say that might be shortwave troughs, but for the most part, I want to get a better answer at that. So yeah, here, the main acknowledgement I wanted to make was for the Storm Prediction Center for making this data publicly available, and so that students like myself can embark on projects like this. So that's time for questions.
Yeah, we get time for a couple of questions.
So great presentation. I definitely like regime studies, so it was very cool. I was wondering if you had also another avenue to look at the over forecasting in particular is human factors. So especially where those events are occurring, they tend to be more deadly. So there's probably a tendency to over forecast. And so I just wonder if that would be something that you could look at in future studies, trying to just kind of look at tornado risk in terms of likelihood of death and property loss, and see if that would be pretty interesting.
Like I figure it would be possible to like go with that. I do have the other clusters, so look at the heat maps for those. I wanted to specifically for this talk look at the kind of the extremes, because those are going to have the highest variation. But honestly, I think I do have the data out there, like to look at specifically the heat maps. You can honestly talk to me later, and I can find that for you if you want. So.
Yeah, hi, that was a great talk. I'd love to chat more after too. But one thing I was wondering is on those most accurate days where the flows seem to be weaker overall and the storms seem to be more spread out.
Do you want the heat maps?
I don't need a specific.
Oh, okay, that's fine. That's fine.
Yeah, on those days, I guess I was wondering, are those, one thought that popped into my mind is, are those lower risk days or lower severity days overall? Is that something you looked at? And maybe more generally, was this whole study across all days or just higher risk level days?
This cited all risks that the SPC issued, so marginal through high. We didn't look at general thunderstorm. The study itself does not specifically have the risk level, like enhanced and above, et cetera. But one of the conclusions that we made, honestly, was with the most accurate clusters, there's a very high likelihood that if you have like a 2% tornado probability and you verify 0, that still goes as accurate because you don't, it still goes as accurate because you forecasted that there wasn't really a high likelihood, and that's true, that you got 0. So that was a big thing too. It's kind of the reason they were so scattered about and kind of least frequency with those was just due to that case. So I would like to honestly look at expanding it more towards the slight over and under forecast too, but I think it's better to stick with accurate just because it'd be kind of unfair to expect perfection.
Yeah, makes sense. Thanks.
Ethan, just real quick, there can be a pretty big difference between the numbers, especially tornado reports that come out in the preliminary data and then the final kind of storm data numbers. I'm just not familiar with Iowa State's site to know which of those they're providing. So do you know that?
So from what I was aware of, Iowa State was providing basically what the SPC has in their verification, which is that preliminary storm reports. So I want to stick with the SPC because that's how they, on their site, I think it was on the maps, I could go back to it, but if you look in their site for what's the risk verification for this day, they'll have preliminary storm reports for that day. So that's what I try to stick with.
Yeah, we should chat later because they can be.
Yeah, no, I know they can, yeah. That's a potential limitation too, is that like you can have one tornado and 5 different people looked at it and said, well, it's tornado, but they're all in different locations. So you can have a larger area for that. So that's something I was aware of. But I figured because that's how the SPC does it, we'll stick with that. So.
Okay, we better move on. Thanks, Ethan.
Thank you again for watching my presentation. I do hope to have some more little updates on research and such as time goes on. And I do actually have a project in the workings that I would like to post on here eventually too. Yeah, first time presenting. It was exciting. Excited to do it again as well. But yeah, so I mean, you can probably tell a little bit of the nervousness at first, especially. So I haven't really had any other notes really. If you have any questions, again, do let me know. I'd be happy to answer anything because again, it's kind of hard with the refraction. I can see, and also just not having as much context. If it's a question you had or something, so you can like just a question you wanted to ask, feel free. I'd be more than happy to answer. So. With that, I just say thank you for watching. I'll see you all in the next forecast or whatever video comes out next. So, adios for now.